Welcome guys to today's class. In today's video, we want to discuss Kirchoffs circuit. Yes, as you can see on the board, this is a typical example of what we call Kirchoffs circuits. We have 4 different resistors given to us, and we are asked to calculate the current in each of the resistors. Now, what is the concept of this Kirchoffs circuit? Kirchoffs circuit has a law. This law describes the relationship among the current, the potential difference, and electromotive force. These laws are of 2 types. One is the junction rule, which we call the current rule. Then the second one is called the loop rule, which we call the what? Voltage rule. When we talk about junction rule, this rule is based on the conservation of charge. This junction rule is based on the conservation of charge, and this rule states that the summation of all the current in the resistor must be equal to what? 0. That is, the current flowing in and the current flowing out, the sum of it all must give you 0. Then the loop rule, what is it telling you? It's saying that it is based on the conservation of what? Energy. And in this law, the summation of what? Voltages in the what? Circuit is equal to 0. And the voltages we talk about includes this potential difference in each of the resistor and this what? EMF. So the sum of it must be equal to 0. They are their rules now. Now, let's see how we can solve this problem we have on the board. First, for this junction rule, which talk about current, you have to pick direction of your choice at this junction. Make sure that you pick direction such that there are current flowing in and there is current flowing out. You can see that from this direction I just pick, this current is flowing into the junction, this one flowing into, but this one is flowing away. Is a good what? Is a good direction to check. If you have it this way and you pick this direction, and you end up picking this direction, it is wrong. Or you pick it this way, this, it is what? Wrong. Because here all the current are flowing into the junction, and here all the current are flowing away from the junction. So they are wrong what? Direction to choose. And so if you have been able to choose a direction such that some currents are flowing into the junction and current flowing out of the junction, the implication is that it is a good direction. Now, from this direction, let's label. We can call this one the first resistor, the second, just take note of what you are calling them, and the what? Fourth resistor. Now, let's assign their current. Do you notice that this resistor and this resistor are in series? We noted that when 2 or more resistors are in series, they will have same current but different voltages. And so this resistor and this resistor will be having one current. That means the current started from here, it moved from here. The current this one is seeing is the one this one will also see. It moves from here to here. Okay? Then this one, because it is I arrow 3, we can call this one I what 2, and we'll call this one I what 3. We are just labeling the current so that we'll be able to know what we are solving. That is about junction rule. Now, this current is flowing into the junction. Some of the current flowing into the junction is I1 plus I2 is equals to the current flowing away from the junction, which is what? I3. So when you add the one flowing in, you equate it to the one that are flowing out. We come up with this formula. We go to loop rule. What what does loop rule states? We say in loop rule, you have to what? Assign a rule of any direction you want. If I assign it like this, it's my choice. If I assign it like this, it's my choice. Okay, let it not be like it's a must you assign it. So if I assign it like this, it's my choice. Also, if I also assign this one like this, it's also my choice. So we have been able to get loop A and loop B. Now, what does loop rule state? It's trying to tell you that when the current is in the same direction with the loop, that current will be negative. And when the current is in opposite direction with the loop, like this one is moving like this and the loop is moving like, so they are in the same direction, this current is negative. Whereas this current will be what? Positive, because they are in opposite direction. And so look at what I will have. For loop what? A, I will be having that this is negative current because it's same direction. So I will be having that I1 times 1 negative. Then this one minus I1 times 2, because we say that we have same current. Then this one is what? We'll be saying it is of opposite direction. So plus I2 times what? 3, right? Then this is negative terminal and this is positive terminal of the battery, positive and negative. So once it's moving from negative to positive, like from here to here, the implication is that this will be positive. I will now say this is equals to what? 2. This is equal to 2. Then for loop B, I will note that here, this is of opposite direction with this. So we have 3I2. This is opposite direction with this. So this current will be flowing like this because this is what have the current. So they are of opposite direction. This one move up, the loop move up, and this current is moving down. So plus 4I, what is it? 4I3. We say that this is I3. So 4I3 is equals to, since it's moving from negative terminal to positive, we say that this will be what? Plus what? 4. Right? So we have gotten that I1 plus I2 is equal to I3, equation 1. We have also gotten that minus I1, please watch it clearly, okay? Minus 2I1. Minus I1 minus 2I1 will give you minus 3I1, right? You have minus 3I1, then plus 3I2 equals to what? 2. Equation 2. Then for this one, we have it to be 3I2 plus 4I3 equals to 4. That is equation 3. Wow. 3 equations to be solved. Now, look at what you do. Since here you have I1 and I2, and here you have I1 and I2 equal to I3, I will say replace this I3 with I1 and I2. That means I will be having 3 plus 4 bracket I1 plus I2 equals to what? 4. So this will be giving me 3 I2 plus 4 I1 plus 4 I2 equals to what? 4. This plus this. So we'll be having 4 I1 plus 7 I2 equals to 4. We hold it. We will call this another equation 1 because then we will pick this one and write it here. Minus 3 I1 plus 7 minus 3 I1 plus 3 I2 equals to what? 2. We'll call this a new equation 2 because this is now in terms of I1 and what? I2 to be solved simultaneously. Okay? There is nothing to what? Eliminate or to remove. So what we do, you do this times is minus 12 I1 This times is minus 21 I2. This times is minus 3 times 4, minus 12. Right? 4 times this, minus 12 I1. 4 times this, plus 12 I2. 4 times is equal to what? 8. And so, to eliminate, we will put minus. This minus this will go. This minus this will give me minus 33 I2 equals to this minus this will give me minus 20. So minus 12 minus 8 is minus 20. Therefore, my I2 will be equals to minus 20 over minus 33 equals to 20 over, so this will cancel this. 20 over what? I2 is equal to 20 over 33. Okay, so we have been able to get the second current, that is I2, to be equal to 20 over 33 ampere. That is this current here. We have been able to get it to be 20 over 33 amperes, right? Now to get the I1, that is the current used by this resistor and this resistor, we will go to equation 1 or equation 2 and put the value of I2 to get our I1. In equation 1 here, we have that 4I1 is equals to, this will go the other side, 4 minus 7I2. And what is our I2? That is 20 over what? 33. Right? And so we'll be having 4 minus 7 times 20. That is 140 over 33. Okay, so since we have gotten this to be this, now we'll look for the LCM. LCM is 33. 1 divided 33. 33 times 4, 132, minus this divide this 1. 1 times is 140. We will say is equals to 4I1. Then I1 will be equals to, this will be minus 8. Minus 132 minus 140 is minus 8, all over, this 4 will come down, this 4 will come down, we have it to be 4, then times 33. So it means that this minus this is minus 8 over 33. We carry this 4 down so that it will divide 8. It will give you 2. Therefore, I1 is equals to minus 2 over 33 ampere. That means minus 2 over 33. That means the current is in the same direction with the loop. Let's check. Is the current I1 in the same direction with the loop? Yes. So it's correct. So we have our I1 to be equals to minus 2 over 33 ampere. We have our I2 to be equals to 20 over 33 ampere. This is negative while this is positive. So to get our I3, yes, we need to bring I1 and I2 here. We now say, okay, minus 2 over 33, this is your I1, plus what is your I2? 20 over 33. Let's see, LCM should be 33. Then minus, this divide this one time minus 2, this divide this one times is 20. Minus 2 plus 20 will give you 18 plus 18, right? So 3 here, therefore I3 is equal to 3 divided this 6, 3 divided this 11, right? We have our I3 to be equal to 6 over 11 amperes. Remember, once it is positive, it means that the loop is in opposite direction with that current. This one is negative because the loop is in the same direction with this current. And because that what we got tallies with what we have on the what diagram, it means we are correct. If we have here to be negative and have I2 to be negative, the implication is that I have to change the direction of this loop after this solving. If here is negative and here is negative, the direction will go this way. You now see the direction, it will go this way. But here is positive and here is positive, and so we will not change the direction. We will not change the direction, because positive means it's in opposite direction with this current, so we leave it like this. I2 opposite in direction with this loop, so this is correct, this is correct. This one minus mean is in the same direction with the current I1, so it have to be minus. So that is how to sort out questions on Kirchoffs circuits. If you enjoyed this video, please don't forget to click like button, share to your friends, comment, yes, comment, and click subscribe. Thanks for watching the video.